Alright, brand new day calls for a brand new video. If you've been following for the past couple of days, we are slowly catching up on, well, I'm slowly catching up on the 30 Days of ML Challenge organized by Kaggle. If you watched my previous couple of videos, we've covered day 1 to day 4. Well, in this video specifically, I'm going to work through day 5. So as we can see here from the schedule, day 5 we're doing lists as well as loops and list comprehension. So they're both lesson 4 and 5 of the Python course. So let me just move back to the Python course. So this is the Python page that's under the courses tab on the Kaggle website. So today we're gonna work through lesson 4 and lesson 5. So let's just begin with with lesson 4, lists. I hope everyone's doing well, by the way. I hope you're doing better at keeping up to date with the challenge that I'm doing so terrible. And by the time I edit this video, it's probably like day, I don't know, like midway through the challenge. But anyway, all right, so let's begin. List. So list is a data structure that is, like the name suggests, it's just a list of objects. So here we can see a list called primes. So this list contains 4 elements with the numbers 2, 3, 5, and 7. Besides numbers, so these are numbers, we can also put strings within a list. So this is an example of a string that is within a list called planets. We can also do a list of lists. So within this list here, so this is the opening of the list, this is the closing of the list, and within this list, we have 3 lists. We have list number 1, that's within our original list number 2, and list number 3. So this is list number 3. So this is what we call a list of lists. You can either write it this way, which I personally think it's easier to see, or you can write it in just like one line, but you need a comma to separate the list that's within your list. All right, cool. A list can also contain a mix of different types of variables. So it can be an integer, it could be a string, and a function. It doesn't have to be a consistent type of variable, which I didn't know. That's good to know. I'm always learning, like, by the way. I'm like okay with Python, but I haven't been practicing, like I said in the last few videos, I've been practicing Python at work. At work, I've just been mostly using R and SQL, so I think this challenge is perfect in the sense that it helps me practice my Python again, just to refresh on some of the things that I used to know, I've forgotten, or some of the things I didn't know completely. All right, let's move on. Indexing. So indexing is how you would access a particular element in a list. So here we are accessing the first element. So the thing with Python is it uses zero-based indexing, which it says here. So what this means is the first element starts with the number 0. So it starts from 0, 1, 2, and 3. So the first element takes the value of 0, the second element takes the value of 1, and so on and so forth. And so therefore, if you want to access the first element, instead of putting the number 1, you have to use the number 0 because we start from 0. Yeah, so it's a bit of yeah, it takes a bit of time to get used to it, but once you get used to it, it's pretty straightforward. So here we want the first element of the list in the list planets. So if we scroll up and have a look at the planets list, the first element is called Mercury, and that is exactly what is being printed out here. So planets square bracket 0 is Mercury. And then the next one is the second element. So we use 1 for the second element. So it's Venus. Which planet is the furthest from the sun. So here we can actually use a negative number, which tells Python we want to access in a different, in the opposite direction. So -1 means we want the end of the list. And so Neptune is the last planet on that list. So if we scroll up again, the last planet on the list is Neptune. So yeah, we're going, rather than starting from Mercury, we're going the opposite direction. We're starting from Neptune, -1, that'll tell us the last element of the list. Beautiful. This is just the same thing. The second last element of the list is Uranus. All right, we can also do slicing. So slicing means we want to specify a starting location and an ending location, and then we want Python to list out all the elements that fall within that range. So here we want from 0 to 2. So the reason why it's 0 to 2 is because when we're doing slicing, we don't include the last number, but we include the first number. So we start from 0, we end at 2 rather than 3. So it's going to print out 0, 1, and 2. So the element the first element, the second element, and the third element. So Mercury, Venus, and Earth. Yeah, so this is another thing that you have to get used to. So look, the first number is inclusive, the last number is exclusive, which is being mentioned here. So starting from the index of 0, continuing up to, but not including index of 3. Another way you can write it is without the 0, just write semicolon followed by 3. So both of these will give you the same result. This one is you start from the second element. Sorry, now I'm getting confused. The fourth element, and then followed by semicolon. This tells Python you want to start from the fourth element all the way to the end. So this will print out Mars to Neptune. So if we scroll up and have a look again, it should be the fourth element until the very end. So 1, 2, 3, 4, which is Mars. We want from Mars, and then we want to print everything until the end of that list. Pretty straightforward, right? Not too bad. So here we have another example. So remember, we want to include the first one, but exclude the last one. So here we want to start from the second element of the list, going until the very end of that list. This one, on the other hand, is this will print the last 3 planets. So we're going back in a backwards direction, the last 3, and then we'll bring it to the end. Yeah, not too bad so far. So the next concept we want to discuss is changing lists. So we can actually change the element of the list using this method. So here we're changing the fourth element of the list to Malacandra. So I believe the fourth one used to be Mars. So we're changing Mars to Malacandra. So this is how you would, so we're assigning Malacandra to the fourth element of the planets list. And so if we print out planets again, as we can see here, Mars has been replaced by Malacandra. Yeah, you can also do it in this way. So this allows you to replace all 3 of them at once. All right, should be pretty easy. I'm just going to move past this. We have a function called len, which gives the length of a list. So you just have to use len, and then within the parentheses, put in the name of your list, and then you'll print out how many elements how many elements exist in that list. There's another function called sorted. So this will sort the planets list in alphabetical order. So E, J, M, and so on and so forth. We have a lot of new functions here. So sum sums up the numbers in the list. So if we pass in a list of integers, I'm pretty sure it works for float decimal numbers as well. I'm not too sure. So once you pass in a list into the sum function, it'll sum up the numbers in that list. So 2 plus 3 is 5, 5 plus 5 is 10, 10 plus 7 is 17. Same thing, we can also apply the max function, which I think we saw from the previous lesson as well. If we, so this just returns the maximum number in that particular list. So the maximum number in this list is 7. Yeah, pretty straightforward. All right, the next one we have interlude object. I'm not too sure what this is. So this, I think, has something to do with like imaginary numbers in complex numbers. You probably won't know this unless you've done like complex, what do they call it? Discrete math or like something like that. Yeah, when you deal with like complex numbers, I think. Yeah, like imaginary, real and imaginary numbers. Yeah, I don't think this is important. I'm just gonna skip past this, or like just spend some time on this in your own time. I'm just gonna skip past this because I don't think it's important. Because I want to keep this video concise. All right, so next one we have append. So you can append an additional element to a list by using this dot method here. So first name, give the name of your list, followed by a dot append, and then specify what you want to append to that list. So it's going to append at the very end. So say, for example, you have a list, and then you do dot append. It's going to append whatever element that you want to add at the very end of your original list. Yeah, you can use help function to see what append does. So as you can see here in our new planets list, we have a new element at the very end called Pluto, which we appended from early on from here. Beautiful. Pop does the opposite. So pop removes the last element of a list. So if we do planets.pop, it will remove Pluto from that list. So as you can see here, our new planets list, after we pop, we have the Pluto has been removed. We can also do dot index. So dot index returns the index number of that particular element. So say for example, we want to figure out what the index number is for the word Earth. It is 2 because Mercury takes Mercury is index 0, Venus is 1, and Earth is 2, and therefore the index number for Earth is 2. Yeah, so if we try to do this, because Pluto doesn't exist anymore in our list, we'll just return an error. Yeah, you can also check like so. Remember previously we did in the previous video we did conditionals where we used 2 equal sign. In order to check if an element is in a list, we have to use the word in. So this is checking if the word Earth is in the planets list. So in this case it's true, and if we do this, it's false. Yeah, so pretty straightforward, not too bad. All right, cool. Yeah, so here we're introduced to another type of data structure. This one is slightly different. It's similar, but it's different. So this one's called tuples. They look the same way as a list, but if you pay attention to how they do the parentheses, it's actually different. So this is round, do they call it round parentheses? Yeah, I'm pretty sure it's called round parentheses. So round parentheses is a tuple. With a list, as we saw from earlier on, uses a square bracket, so it's slightly different. So the key defining feature for a tuple is that it is you can't change it, or in technical terms they like to use the word immutable, meaning you can't change a tuple. Yeah, so that's the key defining feature that differentiates a tuple from a list. Yeah, you can skip past this. Yeah, so see, this is what they mean by immutables, because you cannot modify. So unlike a list where you can do, where you can assign and replace a value, you can replace an element in a list, you can't do that with a tuple. It'll just return an error. Yeah, so many times, like there's a couple of functions, there's quite a number of functions that return an output as a tuple. So here they give an example called as integer ratio. So if you pass in a float into as integer ratio, it will return the fraction form of that decimal. So here we have 0.125, which is 1/8. And so if you pass this in, if you apply as integer ratio to 0.125, it will return 1 and 8 in tuple form. So this is, yeah, so 1, 8. But this is in tuple form, and we know it's in tuple form because it's in round parentheses. So if you want to access the element in the parentheses, we have to do the following. So we have to, so here we're declaring 2 variables, one called numerator and one called denominator, and we want to separate these 2 variables using a comma. That way, when we pass this in, Python is smart enough to assign the first number, which is number 1 here, to numerator, and the second number to denominator. And so once we successfully save those 2 numbers into these 2 variables, we can use them like we normally would with a normal variable. So here we want to print 1 divided by 8, which is 0.125. Yeah, so that's just, I guess, to show you how you can access the elements of a list. So this is how you would do it. Cool. Yeah, this is just another example for swapping 2 variables. All right, so let's start the exercise now without wasting any more time, because I think, yeah, this so far has been pretty straightforward. Yeah, I'm just mindful of time, because once we finish this, we also have another one. And today we have like 2 lessons we have to go through, so I'm just mindful of time. So let's just be quick. Yeah, so the first one is just setting up our notebook. Once it's done, it will print setup complete. While that is loading, let's just move on to question number 1. So complete the function below according to its doc string. So this function is called select second. It will return the second element of a given list. If the list has no second element, return none. Yeah. So we need, sounds like we need an if statement because we have to check if the list has a second element or not. So the first thing we need to do is create an if statement. We want to check the length. I have a bad habit of differentiating length and length because in R, I'm so confused now because it's so bad. Like when you're using multiple languages, you're just like unsure about which one's which. So in Python, it's len, L-E-N without the GTH, but in R, it's the entire word length. All right, so anyway, len L, if len L is greater than 1, we want to return L, the first element. Else, if it's less than or equal to 1, meaning it only has one element, we want to return none. I think that's correct, right? All right, beautiful. Not too bad. Let's move on to question number 2. You're analyzing sports teams. Members of each team are stored in a list. The coach is the first name in the list. The captain is the second. The other players are listed after that. These lists are stored in another list, which starts with the best team and proceeds through the list of the worst team. Complete the function below to select the captain of the worst team. All right. So this is a list of a list. So what this is saying is we have a massive list of all the teams, and each team would occupy a list. And within each team, we have the coach, the captain, followed by all the other players. So here we want to figure out who the captain is for the losing team, the worst team. So meaning we want, in big picture form, in the big list, we want the last element of that list. And within that last element, we want the second element of that list. Just need to figure out how to do that. I think I'm just going to do teams because we want the worst team, so we have to do -1 to access it from the very end, and then from there we want to do 1 because we want the second place, the second member of that team. Yeah, I think that's it. Let me not forget my return. I think this is it, right? This should work. Yeah, beautiful. Cool. Question number 3. The next iteration of Mario Kart will feature an extra infuriating new item, the purple shell. Cool. So this kind of looks similar to our first exercise, right? So the exercise from lesson 1, something like that. So we need to create a temporary to store the first place, racers 0. And then we want to replace races 0 with races -1. So we want to replace the first racer with the last racer, and then we want to replace the last racer to the original racer. Yep, I think that's it. I'm just gonna run this. Beautiful, it's correct. Yeah, it looks very similar to the, if not mistaken, it's the first lesson number 1. Yeah, the exercise in lesson number 1. All right, what are the lengths of the following list? Fill the variable lengths with your prediction. Try to make a prediction of each list without just calling the length. Yeah, so the first one is pretty simple. We have 3 elements, so the length is 3. The second one, I think it's 2. C would be 0, I'm not too sure. The last one is, we want from the second element to the end, so we want these 2. So I think the length is 2. I'm just not too sure about C. Others I'm pretty sure. Yeah, so I'm just unsure about the 0. Let's just run it and see what happens. Yep, beautiful. All right, so we have a spicy question. Ooh, spicy. We're using lists to record people who attended our party and what order they arrived in. For example, the following list represents party with 7 guests. 1, 2, 3, 4, 5, 6, 7. This is the first person who showed up. This is the last person that showed up. A guest is considered fashionably late if they arrive after at least half of the party guests has arrived. They must not be, however, they must not be the very last guest. So this first condition is saying that if it's past the midway mark and if it's not the last person to arrive, then we want to return it's true. All right, yeah, that makes more sense. Cool. Yeah, sorry I didn't get that one, but I'm sure, yeah, I'm sure you guys will figure it out because you guys are are smarter than me. All right, I'm just gonna keep going and go to the next exercise. So loops is another concept that you can know in programming. So we have if-else conditionals. The next thing you need to know is loops, which allows you to repeat a certain operation repeatedly. Yeah, we'll have a look at some example as we go through this. So here we're introduced to, is this the right? Yeah, it is the right one. So here we have a list of planets. Again, this is the same one we saw from the previous exercise. We want to loop through this planets list, and then we want to print each planet followed by a single space. So it'll loop through each element within this list, and at each element print a single space that separate those planets. And this is how you do loops in Python. So for planet in planets, so planets is this list. For each planet in this list, print the planet itself, and then followed by a single space, and then move on to the next planet. So print Mercury followed by a single space, move on to the next planet called Venus, print it out, space, print out the next planet, space, print out the next planet, space, and so on and so forth. So we want to multiply all of these numbers together. So we start from the first one, we multiply by the second one, and then we want to update. So see how we're updating the variable product here. So once we let's start from 2. So 2 will multiply by, so product is initialized to 1. So this initially this would be 1. 1 times 2 is 2, and then we want to update the variable product to 2. 2 times the next mult, which is 2 again. So 2 times 2 is 4. We want to update the product again. 4 times 2 is 8. 8 times 3 is 24. 24 times 3 is 72. 72 times 5 is 360. And so therefore, as a result, product equals to 360 once we loop through all of that and multiply them together. We can also loop through each character in a string. Loop not only applies to a list, but we can also apply it to a string as well. We can apply it to a string as well. So here we can loop through each character in a string. And here I think we're checking if we're picking up the characters which is in capital letter. So here we can see this letter is in capital, this letter is in capital, this letter is in capital, and so on and so forth. So what this for loop is doing is it'll loop through each character. So it'll go from S, T, E, G, and so on and so forth, and pick up on a character which is uppercase. So here we have a condition. So this is the condition that we're setting in order for Python to know which character specifically to want to pick up. So once it satisfies this condition, we're going to print it out, followed by, well, this is, I don't think this is a single space, it's just, yeah, empty. So if it's uppercase, print it, and then move on with the remaining of the string. If you see another capital letter, print it out again, and so on and so forth. So in the end, it'll print hello, because H, E, we have an L here that's capital, we have another L here that's capital, and an O here that's capital. Yeah, so it's managed to print out all the letters in capital form. Next we have range, which is a function that returns a sequence of numbers, which turns out to be very useful for writing loops. Let's look at an example. So for I in range 5, so range is actually, so if you do range 5, it actually automatically creates a list that starts from 0 to 4. So 0, 1, 2, 3, 4. And so if we print each element within range 5, it will just print 0, 1, 2, 3, and 4, which is the elements in range 5. Yeah, you can play around with it. I think it'll make more sense as you practice it on your own, just to convince yourself how it works. Here we have a new, this is a different kind of loop. So what we just looked at then was a for loop. We have another kind of loop called while loop. So while loop is a little bit different in the sense that you don't specify a list you want the for loop to look through, but instead with a while loop you have to set a condition to exit the loop or a condition to end the loop. So here we see the condition is as long as I is less than 10, we want you to do this. Once I is greater than or equal to 10, this loop will this loop will finish. So let's see what this program is doing here. So we initialize the variable I to 0, and then we create this while loop that says if I is less than 0, I want you to print I followed by a space, and then I want you to update I by 1. So alright, let's just I guess talk through in a programming sense how this is working behind the scenes. So we begin with 0. So 0 is less than 10, and so therefore we want you to do this. So print 0 followed by a space, and then update 0 to 1, and then we go back to the beginning of that loop again. Is 1 less than 0? It is. Print 1 followed by a space, update 1 to 2. Is 2 less than 10? It is. Print out 2 followed by a space, and so on. So we do that until we get to 9, because once it reaches 10, it will exit the for loop, because 10 is not less than 10. 10 is equal to 10, and so therefore the while loop will just end there. So and therefore, as a result of that, you'll get all of these. So we'll print from 0, which is where we started off. That's where I was being initialized. So we want to print everything from 0 all the way to 9 with single space in between them. All right, so here we're introduced to list comprehension, which is a fancy feature in Python, which I particularly quite enjoy. So how this works is it's like in a for loop, but it's in a list form. It's a bit hard to get your hand around, but I usually look at where the word for starts. So this tells us where what you want to loop through. So here we are looping through the range. We're looping through range 10. So range 10 is a list that starts from 0 to 9, which contains the elements 0 to 9. So for each element in range 10, we want to take the square. So we start from 0, 0 square is 0, and then we move on to 1, 1 square is 1, 2 square is 4, and so on and so forth. So therefore we get 0, 1, 2, 3, sorry, 0, 1, 4, 9, 16, and so on. Yeah, hope that makes sense. So just look at where the word for starts. So that tells you what you want to loop through, and then look at the very beginning of that sentence. So that tells you what transformation or what numerical calculation we actually want to apply. So here we're taking the square, and we're looping through this list. So here is what we would have done if we didn't use list comprehension. It still works, but as you can see here, this one is more robust. It's more tight. It's, I think, yeah, although it takes some while to like get used to, but I think it's something that you should definitely pick up. We can also add an if condition within the list comprehension. So this works the same way. So I would suggest that you look at the for loop first. So here we're telling Python to loop through the planets list and pick up on for each planet if the length of the planet, so meaning if the word count of that particular planet is less than 6, we want to print it out. Or at least we want to store it, not print it out, we want to store it in this variable called short planets. So here we can see there are 3 planets that have less than 6 characters in their word. So those 3 planets are Venus, Earth, and Mars. Yeah, so this is another, I guess, example. So we're looping through each planet in the planets list. If the number of characters in the planet is less than 6, I want you to make that planet an all uppercase plus an exclamation mark. So here we have, this is the output. You can also do list comprehensions in multiple lines, but I probably won't suggest, if you're doing list comprehensions, you might as well just do it in one line, because I personally think it's meant to be a one-liner, so I don't think there's a point if you do multiple lines. If you're planning to do multiple lines, you might as well just do like a normal for loop. I think it looks, it's much easier to follow. 32. So this, I think, will just print 32 for the number of times there is the number of times equal to number of elements in the planets list. So here we have 1, 2, 3, 4, 5, 6, 7, 8. Yeah, pretty straightforward. What is it trying to do here? List comprehensions combined with functions like min, max, and sum can lead to impressive one-line solutions for problems that would otherwise require several lines of code. For example, compare the following 2 cells of code that do the exact same thing. So here we have a function that is called count negatives. So it returns the number of negative numbers in a given list. So for example, in this list here, we have two negative numbers. Excuse me, 2 negative numbers. It'll return 2, and this is how it works. I think at this point you guys are pretty comfortable, so I'm not going to go through this. So this is way more concise version of this function on the top, and this is utilizing list comprehension. So I think this goes to show how robust and how effective list comprehension is, if provided you know how to use it and if you're careful enough. So this, again, we start from the for loop. This is how I like to use it. So loop through all the elements in the nums list and check if the number is less than 0. If it is, I want you to store it into a list. So store into a list, and then once you've looped through every single element in the list, I want you to return the length of that list. So yeah, so store all the negative numbers in that list into a new list, and then apply the length function to that new list. So this does the exact same thing as this, but this one is clearly much better because this is one line. It saves time, saves energy, so it's a very powerful tool if you know how to use it. So this is another way you can do it. So this is using sum. Yeah, you can figure this out this yourself. I'll leave this as an exercise. All right, so let's move on to the actual exercise for this lesson. All right, so question number 1. Have you ever felt debugging involved a bit of luck? The following program has a bug. Try to identify the bug and fix it. So this function is called hasLuckyNumber. It'll return, this function will return whether the given list of numbers is lucky. A lucky list contains at least one number divisible by 7. So for num in nums, if num is divisible by so we want to find the error and then we want to fix it. Try to identify the bug and fix it in the cell below. If the first number is not divisible by 0, it will just return false. But there could be subsequent numbers that are divisible by 0. So if you just check the first number, so this one will immediately return false if the first number is not divisible by 0. But that's not what we want. We want to check through the entire list. So I think that is the bug there that we have to fix. So let's think about how we can fix that. So I think the else statement shouldn't be within the for loop itself. It should be outside of the for loop, meaning we want to loop through every single element. If we don't find a number that's divisible by 7, so meaning once we finish all of this loop and if it doesn't return true, we want to return false. I think that's a better way of doing it, because if the else statement falls within the for loop and if the first number of that list is not divided by 7, it will immediately return false. But that's not what we want. We want to check every single element, not just the first one. Yeah, so I think this is the right way of doing it, I think. All right, beautiful. Move on to the next question. Look at the Python expression below. What do you think we'll get when we run it? When you've made your prediction, uncomment the code and run the cell below to see if you're right or not. Oh, it's an error. Of course. R and Python have some libraries like NumPy and Pandas compare each element of the list to 2. So it's called an element-wise comparison. Okay. Implement a function that reproduces this behavior, returning a list of booleans corresponding to whether the corresponding element is greater than n. Okay. Cool. So we want to loop through. So L will take a list, and then we want to compare it to the variable called thresh, which is threshold, I believe, short for threshold. If it's greater than threshold, we want to return true, otherwise return false. So this involves a for loop because we have to loop through that element. So for I in L, if I so what do we want to return? We want to return a list. So we need to initialize a variable for our result first. So I'm just initializing this as an empty list in order for us to store the results. For I in L, so we want to loop through the L list. If I is greater than thresh, we want to append the rest list with true, else rest pen false. And then once you finish looping everything, we just want to return our list. I think that's it. Beautiful. Question number 3, complete the body of function below according to its doc strings. So our function is called menu is boring. Given a list of meals served over some period of time, return true if the same meal has been served 2 days in a row, and false otherwise. Would my code would have, I think my code would have worked if I fixed this. I'm not too sure. Anyway, so this is the correct answer. I'm just gonna, mindful of time, I'm just gonna skip past this and do question 4. Complete the following function to calculate the average value per play of the slot machine. The exact value of... How do I know if my answer is correct or not? If your answer is way higher than 0.025, then maybe you forgot to account for the $1. Oh, you have to account for the cost of play as well. I might have gotten this wrong. But yeah, let me know in the comment section how you went with this one. I'm just gonna end the video here because it's getting way too long. All right, check back in. I hope you enjoyed this video. Check back in with me as I spent today just going through all the other Python lessons. I hope you enjoyed this video. I hope you learned something. I definitely learned something. I didn't intend for these sort of videos to be completely informative. I just wanted to record myself doing all these challenges because I want to show you guys and be transparent with my level of knowledge in terms of when I'm coding, what I'm paying attention to and what I'm thinking. But I hope you manage to find some value in that. I just want to post all this up there and just be transparent with you guys. All right. In any event, I'll see you in my next video. Please take care, and I hope you're enjoying the challenge so far.